Good morning, everyone. The next problem on balancing of rotating masses, the fifth one. Four masses, we have four different masses. Mass A, B, C, and we have D also. Is missing here. D is equal to 4 kg. Are placed at radius 100 millimeter, 125 millimeter, 200 millimeter, and 150 millimeter. The distance between the planes are 600 millimeter. All the planes are placed at a distance of 600 millimeter. Find the required mass A. Mass A is unknown here. Required mass A and the relative angular positions of the four masses to achieve complete balance. Here the angle is not given. You need to find out the mass of A as well as the angular position of three masses B, C, D, or A, B, C. We'll take one mass as a reference mass. So that angle will be 0 and the remaining angles we need to find out. That is the question. Now let us write the given data. Given data. Given data. First one, we have given mass A, MA is unknown, and mass B, MB is equal to 10 kg. MC, mass of C is 5 kg, and mass of D is equal to 4 kg. It is given in the problem. Placed at a radius RA 100 millimeter is equal to 0.1 meter. Next, RB is equal to 125 millimeter is equal to 0.125 meter. RC is equal to 200 millimeter is equal to 0.2 meter. RD is equal to 150 millimeter is equal to 0.15 meter. So this is the given data. Now the distance between the planes are given. Distance between A to B is 600. It is equal to 0.6 meter. B to C is equal to 600 is 0.6 meter. C to D is equal to 600 millimeter is also equal to 0.6 meter. Now the questions we need to find out what is the mass A, that is the question, and we need to find out the angles theta. Theta of B, theta C, and theta D, as well as theta A. We need to find out the angles of all four masses. So that is the question. Now, let us go to the next step, step 1. Step 1, that is space diagram. Space diagram. So, space diagram, we have four different masses. Let us draw the side view because all the masses are rotating in a single plane, not in a single plane. It is in a different plane A, B, C, D. So draw a line, a straight line or a horizontal line. It is considered as a reference line. After drawing the reference line, just make a dotted line because it is a reference line, or let us consider this as an axis. After drawing the reference line, now we have four different planes A, B, C, D. Let us draw the first plane, plane 1, A, B, C, and the last plane is D. So after drawing the plane, you need to name these planes. Okay, the first one, let us take it as A, plane A, plane B, plane C, and plane D. Now, the distance between the planes are A to B is 600, B to C is 600, C to D is 600 millimeter. So let us go to the distance. Yeah, we'll show the distance somewhere here. Yeah, the first one, A to B, is 0.6 meter. B to C also it is 0.6 meter. C to D also same, it is 600 millimeter or 0.6 meter. All the distances are equal, that is 600 millimeter. Okay. After that, now we need to go for the side view. There is no other data given related to the front view. Let us go to the side view. Mark a point somewhere here. This is a point on a shaft. Now we need to take the mass as a reference mass. One mass as a reference mass. Either you can take A or B or C or D. Whatever it may be, you can take one mass as a reference mass. Here we have option A, option B, C, and D. Which one you need to select? You need to take a proper mass as a reference mass in the side view. Either you can take A, B, C, or D. Which one? So you cannot select A because A is unknown mass. Mass A is unknown, as well as angle A is also unknown. So you cannot take A as a reference mass. Let us go to the B. B is 10 kg. Mass is known, but angle is unknown. So one is unknown, but A, if you consider A, both are unknown. Mass A is unknown as well as angle A is also unknown. But B, mass is known, but angle is unknown. Similarly, C also, mass is known, angle is unknown. D also, mass is known, angle is unknown. You can take B or C or D as a reference mass, not A. You cannot select A because A is a unknown mass both in angle as well as mass. So B, it's better to select B. B, I am going to select B as a reference mass. So draw B as a reference mass. Reference mass means it is at an angle of 0. An angle of 0. Otherwise, you cannot solve the problem. So B as a reference mass. My reference mass at an angle of 0. So positive x-axis indicates it is a 0-degree line. So mass B is taken along the 0-degree line or positive x-axis. Now, let us draw mass C, D, and A. Three masses are remaining. C, D, and A. Let us go to the next mass. Either you can take C, D, or A because angles are not given. So angle of C is not given. Angle of D is also not given. Angle of A is also not given. You can take anywhere because once you fix the mass A, then it will be at 0-degree angle, but the remaining masses will be somewhere here because we need to find out those angles. Let us draw mass C. So this is M. Let us take MC. Next, MD somewhere here. You no need to measure the angle because angles are unknown angles. So that's why this is MD, and we'll show MA somewhere here. So this is MA. So angles are unknown. So let us mention this angles. This is, let us consider this is the mass of C. The corresponding angle is theta C with respect to mass B because we have considered mass B as a reference mass. Next is MD. The corresponding angle of D is M theta D. The last one MA. The corresponding angle of A is MA. MA. So that is not MA, that is theta A. Theta A. So we have all the angles here. We need to find out those angles. Once you mark all the angles with respect to mass B, so next is the tabular column. Tabular column. So next step 2, table or tabular column. Tabular column, we have 4 different masses, 4 rows, but 6 columns. 6 columns, because we have to take a couple also. Planes, masses are rotating in a different planes. That's why it's taken 6 columns. And for plane, mass, the radius of rotation, centrifugal force, distance between the reference plane or distance from the reference plane. Last column is for the couple. Next is, first one is the mass, sorry, plane. Second one, mass in kg. Next is the radius of rotation, radius r in meter, centrifugal force divided by omega square kg meter. This is distance from rp reference plane meter. Last one, couple divided by omega square kg meter square. Now planes A, B, C, D. We have 4 planes A, B, C, D. Next is the mass of A is unknown, that is MA. Mass of B is 10 kg. Mass of C is 5 kg. Mass of D is 4 kg. It is given in the problem. Next, radius of rotation of A is 0.1 meter. This is 0.125 meter. This is 0.2 meter, 0.15 meter. Next, if you consider the centrifugal force, here this is 0.1 MA. This is the answer if you need to multiply this with this. So this is this, if you multiply this with this, we'll get the answer as this one. If you multiply this with this, we'll get the answer for the couple. So if you multiply this one, 0.1 MA, 0.1 MA. Next is, if you multiply this with this, you will get 1.25. Next is 0.2. If you multiply this with this, sorry, that is 1. This is 0.6. So the couple, centrifugal force. If you see the centrifugal force, is it, you just check whether it is possible to draw the force polygon or not. Yeah, but let us verify whether it is possible to draw a force polygon or not. Here, this is the polygon with the 4 edges, 4 sides. 3 are known. Of course, 3 are known, but 1 is unknown. Let us forget it. Unknown. And 3 are known. But what about the angle? Angle of B is known, but angle of C is unknown. Angle of D is also unknown. And angle of A is also unknown. There are 3 unknowns. You cannot draw the polygon. See, look at this. I'm going to try to draw this polygon, force polygon. So whether it is possible or not, force polygon. So force polygon, here we have force polygon. The first one is unknown, A. Let us go to the next one, B. B is a reference mass, so that's why I'm going to take it as O. B 1.25. You can take a proper scale and draw 1.25. This is B. After B, let us go to the next one, 1. But what is the angle? Angle of C is unknown. You cannot draw that line. So we'll be stuck here. So you cannot continue. So that's why you cannot draw the force polygon. Let us go to the couple polygon. So the couple polygon, let us go for the couple polygon. To find out the couple, you need to find out the distance from the reference plane. Means you need to mark the reference plane in the previous figure, front view. Reference plane, it is not a reference mass. Reference mass is B, but reference plane is not identified. Go to the previous one. Yeah, this four masses are the four planes are the A, B, C, D planes are there. In that, we need to select a proper plane as a reference plane. Which plane you need to select as a reference? Here we have B, C, D. Which one? B is a reference mass, but it is not a reference plane. Please remember. So it is not a reference plane. You need to select a reference plane here in the front view. So reference plane, either you can select A, B, C, or D. Which one you need to select? B, if you select B, here the mass of B is known. Angle of B is also known. You cannot take this mass as a reference mass, because if you have a known values, if you make it 0, if you take a reference mass as B, what happens in the tabular column? B as a reference mass, the distance between the reference mass, reference plane with a B will become 0. This term will become 0. Means you are making this term as a 0. So making a known quantity into 0, there is no use. So you cannot solve the problem. Don't make any known value to 0. Select the plane in such a way that you need to keep maximum known values in the last column or a couple. So if you select B as a reference plane, then the couple will become 0. Means you are making this term as 0. That is a wrong thing. So that's why B you cannot select. C you can select, because C, if you select C, then automatically the C to C will become 0. C to C will become 0 and answer will be 0. So here also mass of C is known. Mass of C is known. Mass of C is known, but angle is unknown. Of course, it is unknown. If you make this as a reference plane, then the couple due to C will become 0. Force is known, but couple will become 0. So that is also wrong. Next, D. If you make D, D will become 0, and here also it will become 0. So we'll get value here, we'll get value here, but it will become 0 here. So that is also wrong, because you are knowing this mass, but you are making intentionally it will become 0. You are going to make it 0. So that is also wrong. The other thing, the first mass, mass A. If you make mass A, what happens? A. Mass A is unknown. MA is unknown. And angle of A is also unknown. So both the quantities or both the values are unknown. It's better to make A as a reference plane. If you make A as a reference plane, so the entire term couple will become 0, so angle will become 0, because angle, no need to take angle, because the term becomes 0, means no need to take it in force polygon or a couple polygon. So that's why A will become 0, so that it can go for the couple polygon. It will be a triangle with known quantities. So all three terms will be known, because B is known angle, 0 angle. C and D are known angle, but masses are, the couple will be knowing. So that can be drawn as a couple polygon. So better to select A. A is a reference mass. So you cannot select B, C, D. Why? Because if you make any B or C or D as a reference plane, the term will become 0. Means you are making that known term into 0. So there is no use of that. You cannot solve the problem. If you make A as a reference mass, a reference plane, then A term will become 0, because already it is unknown. You're making it 0. That's all. Already it is unknown, this term. So you are making it 0. So that's why you can solve the problem. So reference mass, you go to the previous slide. So reference mass is, or the reference plane is R, P as A, and you take positive distance in the right side, negative distance in the left side. Negative. Okay, now tabular column. Here, the distance from the reference plane. Distance from the reference plane. Distance of A with respect to the reference plane. Reference plane is A. Distance from A is 0. 0. Answer will be 0. Next, distance from the reference plane B. B to A. B to A is reference plane. Reference plane to B is 600.6. Next, distance from plane C with respect to reference plane, 0.6 plus 0.6, that is 1.2. Next is distance from the reference plane to D is 0.6 plus 0.6 plus 0.6, that is 1.8. Next is the term couple, become 0 here. This is, if you multiply this with this, you will get 0.75. And if you multiply this one, this 1.2, last one 1.08. This is the couple. Now we can draw the couple polygon. Here this part is 0, forget it. Here this is angle is 0, but magnitude is also known. Here angle is unknown. If you have a triangle, look at this. This is the triangle. First one, B. O, you take a B as 0.75. We'll get a point B. After that, you're going to draw a reference 0. Then C is angle is unknown, but the length is known. Length is known. You take a compass and draw 1.2, or take compass length as 1.2 and cut the length here, somewhere here. Then last one, D, mass is known, that is 1.08. Take 1.08 in compass and you cut it here from this point. It is a triangle. Triangle with all three edges are known, one angle is known. Then you can draw the triangle easily. Join this and you just draw a reference line. This is the angle of, this is C, D, this is C. So this is the method to solve or to draw the couple polygon. So let us go to the couple polygon. Next step, couple polygon. Step 3, couple polygon. You cannot draw the fourth polygon here, couple polygon. So scale, you need to take a proper scale. Scale is here, the maximum value is 1.2 is the maximum couple. So you can take 5:1 scale. 1 centimeter is equal to 5, or 1 kg meter square is equal to 5 centimeter. 1 kg meter square is equal to 5 centimeter. 5 centimeter. Now let us draw the couple polygon. Starting point, the first one, first mass is 0. Second is B. B is a reference mass, that is 0 angle. The length is 0.75. 0.75 into 5, because 5 is to 1 scale. 0.75 into 5, that is 3.75 centimeter. 3.75 centimeter. Let us draw. Let us mark a point somewhere here. Yes, O. B is 3.75, because B length is 0.75 kg meter square. 1 kg meter square is equal to 5 centimeter. 0.75 will become 3.75. 3.75. 3.75 at an angle of 0, because it is a reference mass, 0 angle. .75. So this is point A. This is 0.75. This is the direction. After drawing this first mass, you need to draw the reference line, 0 degree line, thin line. Next is C. Mass C is couple C is 1.2. 1.2 into 5 centimeter. 1.2 into 5 centimeter will get 6 centimeter length. 6 centimeter length. You take a compass. Take a compass. Mark 6 centimeter. From this point, because angle is unknown, from this centimeter, you cut the length. Just draw an arc like this. From this point, draw an arc. Yeah, this is an arc. After drawing arc, next is, let us consider, if you know the angle of C, you mark somewhere here and you are going to draw the reference line and you are going to take an angle of D and you are joining this, right? It will be joined here because it is a complete polygon. It is a closed polygon. To close it, you need to reach this point. So it is a reverse process in such a way that you need to take a point, this point, couple D is 1.08. If you take 1.08 into 5, we'll get 5.4 centimeter. Take 5.4 centimeter in the compass, mark 5.4 centimeter. 5.4 centimeter, cut the length. See, just take this and cut it here. We'll get a point here. This point is B. Point B. So now I'm going to draw the line. This line, point with this point B, C. Means first point A, O. So this is unknown angle. Mass are known, but unknown angles. Angles are unknown. You need to measure the angle now. Okay. So this is the reference plane. This one is a reference plane. You just draw a line like this because we have taken all the angles with respect to the reference plane. So this is unknown angle. Unknown angle, and this angle is actually theta C. Next is, if you measure the angle from this line with this one, we'll get theta D. That we need to measure. So this is 1.2. This is 1.08 length. So corresponding angle, we have theta D. If you measure theta C, the protractor will get 118 angle, 118 degrees. Theta D will get 261 degrees. Please make sure that you are getting the same answer. Plus or minus 5 degree is acceptable, not more than that. The difference should be plus or minus 5 degree. Okay, if you know the angle theta C and theta D, you can go for the force polygon now, because we need to find out the mass of A and angle of A also. So angle of C and D, we know. Angle of B is 0. Angle of C and D is known here from the couple polygon. Next is, so we need to find out the mass of A and as well as angle of A. Here B, C, D angles are known. We need to find it. So here now we need to go for the couple polygon. Force polygon. Force polygon. Step 4. Force polygon. You need to take a proper scale. You see the magnitudes. Here also the magnitude is, the maximum is 1.25. So better to take a scale as scale 1 kg meter is equal to 5 centimeter, same scale as the previous one. Okay, let us mark the first one. First one, mark O as a reference. Okay, let us go to the A is unknown. You just make it 0. This is unknown. Next B is 0 angle, but the length of B, force centrifugal force of B is 1.25. 1.25 into 5. 1.25 into 5 will get 6.25. 6.25 centimeter along 0 degree. 0. 6.25. Okay, this is B. Sorry, OA. This is the length 1.25. After this, you need to draw the reference line, 0 degree line at point A, 0 degree line. Next, mass B. Mass B or mass C is 1 means 5 centimeter. Angle of C is, see the next force couple polygon. Angle of C is 118. Angle 118. You take angle as 118 on the compass. Sorry, protractor 118. 118 somewhere here. Length is 5 centimeter. Length is 5 centimeter. Okay, 5 centimeter length. This is the point B, and the length is 1.0. The corresponding angle is 1 theta C is equal to 118 degrees that we have found in the previous figure. Next is the reference line here from point B, 0 degree line. So theta or the mass D is 0.6 into 5 centimeter. 0.6 into 5 will get 3 centimeter. 3 centimeter, but the angle of D is 261 degree Celsius. 261 degree. Take 216, angle 216. Sorry, 261. The length is 3 centimeter. 261. 270 exactly vertical. 270. So this is 216. Yeah. So this is 3 centimeter. 3 centimeter means 0.6 kg meter. But the corresponding angle is theta D. Theta D is 261 are taken because we got 261 in this couple polygon. So after reaching this point is C, point C. Now couple polygon must be closed for the balancing of the rotating masses. You need to join point C with the first point with a dotted line because it is unknown mass, and the direction is, what is the magnitude? This magnitude is, you see the table, it is 0.1 MA. 0.1 MA. And the corresponding angle, you need to measure the angle from the reference line. Reference line is always positive x. So if you measure the angle from the positive x, we'll get theta A. This is theta A. So calculation, see the calculation. Calculation. Zero point 0.1 MA is equal to length of OC into scale. Scale is very, very important. Is equal to length of OC. If you measure the length of OC, we'll get 3.8 centimeter, 3.8 centimeter into scale. Scale 1 kgm is equal to 5 centimeter. 3.8 centimeter is equal to 1 by 5. 1 by 5. Because we have taken 1 kgm is equal to 5 centimeter. So it is equal to, so MA is equal to 3.8 divided by 5 into 0.1. We'll get the answer 7.6 kgs MA. 7.6 kgs, and theta A is equal to, if we measure the angle, we'll get 203 degrees. This is the end of the problem. So this problem is very simple problem, but while selecting the reference plane and the reference mass is very, very important. If you do mistake, it will be wrong. So I'll repeat the problem. So here, this is the problem. Masses are given, MA is unknown, but all the masses are given, but angles are unknown. So after that, you need to draw the space diagram, A, B, C, D, side view. For side view, we need to take a proper mass as a reference mass, means 0 degree angle. Mass B we need to take because B is known. You cannot select A. A is unknown, both angle as well as mass. You cannot select A, B as a reference mass. Either you can select B, C, or D. I'll select B as a reference mass in the side view. So here, so that's why it is a reference mass. Next is a table. If you find out the centrifugal force, you cannot draw the centrifugal force polygon because here we have all the angles unknown and mass is also unknown, A. That's why you can go for the couple polygon. Couple polygon, to find out the couple, you need to select a proper reference plane. While selecting the reference plane, you need to see, don't make the unknown values into 0, because here B, C, D are known values, known forces. But if you select this B, C, D as a reference plane, then that term will become 0. It will be complicated. That's why A as a reference plane, because A is both mass and angles are unknown. That's why A as a reference plane, that is a reference plane. You need to take up the distance from the reference plane. This is the reference plane. We'll get a couple. One term will be 0 and 3 term will be known. So you can draw the couple polygon. Draw the couple polygon. So this is the couple polygon. Draw the couple polygon. It's a triangle. So we'll get a theta C and theta D in this polygon. So same data will be used for the next force polygon. Force polygon you can draw with a proper scale. That is 1 kg meter is equal to 5 centimeter. Find out the value of MA and theta A from the couple polygon. Thank you.